look at solution for this very interesting question. That is the process of conversion of ice at minus 10 degrees centigrade into steam at 100 degrees centigrade. Here a case of conversion of 1 gram of ice at minus 10 degrees centigrade into steam at 100 degrees centigrade. How much work will be done in this process? Here the data is provided in CGS, that is in the calorie units. So let us continue the problem solution with the CGS units only, but at the end we can convert the work done in joules unit by using our joules mechanical equivalence. Now here in the given process, of conversion of ice at minus 10 degrees centigrade into steam at 100 degrees centigrade, the different steps are as shown in the figure. Here very clearly in the figure we have mentioned it, that is ice at minus 10 degrees centigrade is converted to ice at 0 first, and that ice at 0 converts to water at 0 by absorbing heat in all this process. That's why it's shown upward arrow mark. And water at 0 converts to water at 100, and water at 100 converts to steam at 100 degrees centigrade. Now in these different steps the heat absorption that is involved can be given as follows. Ice at minus 10 to convert as ice at 0 degrees centigrade, say the amount of heat that is required is some Q1 is equal to mass of ice. In all these cases of course it is given 1 gram, but as a notation let's use m grams of ice being involved in the process. M into specific heat of ice, this is conversion of ice to ice only but rise of temperature, so ms theta formula, mass into specific heat of ice into the rise in temperature, that is theta minus of minus 10. So here the final is this theta is 0 degrees only, some theta, not that it is 0 because we are raising it from minus 10 to 0. So 0 minus of minus 10. So this is the rise in temperature is by a magnitude of 10 degrees centigrade, minus 10 to 0. And then ice at 0 to convert to water at 0 degrees centigrade. This time there is no rise in temperature, but the phase, that is the state of matter, is changing from solid state to liquid state. So latent heat of the process will be involved. So that is latent heat of ice in the process of conversion of ice to water is involved. Say some Q2 is involved, that is mass into latent heat of ice. Here water at 0 is now becoming as water at 100. Again the phase remains to be same as water only, but there is a rise in temperature, so ms theta formula to be used. So Q3 is equal to, it is mass into specific heat of water into, there is a rise from 0 to 100, so 100 minus 0. And then here water at 100 to convert it to steam at 100. This time there is no rise in temperature, but there is a change of state. That is water, that is liquid state to vapor state is changing. And in that process the heat absorbed is latent heat. So Q4 is equal to m into latent heat of steam. So in the different stages the heats involved are Q1, Q2, Q3, Q4 respectively as shown. So let's write all this in our equation. So here heat required is equal to Q equal to Q1 plus Q2 plus Q3 plus Q4, and which is equal to, here the values let us by formula let us substitute first. M into specific heat of ice into here 0 minus of minus 10 plus here Q2 is m into latent heat of ice plus Q3 m into specific heat of water into 100 minus 0 plus m into latent heat of steam. These are the different stages that are involved, and this is equal. Now let's go for substitution of all the values. Here mass is 1 gram given. Let's solve all in the units in which the calorie unit is given, and that is here CGS and calorie. That is 1 gram into specific heat of ice as given 0.5 calorie per gram per degree centigrade, and here this value is 10 plus again 1 gram latent heat of ice is 80 calorie per gram given, and plus 1 into specific heat of water is 1 calorie per gram per degree centigrade, and this is 100 plus here this is 1 into latent heat of steam is given 540 calorie per gram, that's given. So by adding all these values here, the value comes to be 725 calories. But it is asked in the way of work done. So the heat absorbed by the phenomenon, by the process, is 725 calories. And now let's use Joule's mechanical equivalence. So now by Joule's mechanical equivalence, we can say the work done W equal to JQ equal to J is, we know, 4.2 joule per calorie, 4.2 joule per calorie into the heat in calories, that is 725 calories. So you see, this is joule per calorie and this is in calorie unit, so it remains in joules, and that value is 3045 joules we are getting. So the work done in this process of conversion of 1 gram of ice at minus 10 degrees centigrade to steam at 100 degrees centigrade is 3045 joules, and hence option 1 is our correct answer.